Okay, so once again, good day everyone. So this time our topic is very important in our field because this will focus on the secure software development. I just want to discuss more on best practices, frameworks, and resources. So just how important is building secure software today? Considering the recent surge in successful cyber attacks taking advantage of software vulnerabilities, no, it's become essential for organizations to purchase and use only the safest software. So I don't know if you're familiar with SolarWinds, no, dependency confusion, and Mimikatz, no. So do any of these sound familiar? All are a recent example of how threat actors use software vulnerabilities to further their malicious endeavor. So SolarWinds may be the most famous. This will be an example of a software supply chain attack, no, which occurs when hackers infiltrate a vendor's infrastructure and infect, no, software before it's shipped to customer. Today, no, protecting information is paramount, as it's at the epicenter of every business process and relationship. So presidents are issuing executive orders on cybersecurity actually. So the software handling today's data is under assault, and it's the software, not firewalls or intrusion detection systems or anything else, that behind the majority of successful cyber attacks. In this discussion, we'll be able to share the best practices and frameworks for building secure software and how to identify and respond, no, to vulnerabilities early in the development process when it costs less and is more effective. Okay? So in addition, we will be able to highlight actually the expert develop resources you can leverage, no, for your own security software development effort. Okay, so by the way, what is secure software development? No? Secure software development is a methodology or often called or often associated with DevSecOps, no, for creating software that incorporates security, no, into every phase of the software development lifecycle. Security is of course, security is baked into the code, no, from inception rather than addressed after testing reveals critical product flaws. No? Security becomes part of the planning phase, incorporated long before a single line of code is written. Traditionally, security is viewed as an impediment to innovation and creativity by developers that creates delays in getting the product to market. So this thinking hurts a business bottom line, as it's 6 times more costly to fix a bug during implementation and 15 times more expensive during testing that to fix, no, the same bug during design. And most importantly, how happy will customers be with the cool new features of an application if the product is laden with vulnerabilities for hackers to exploit? No, security deserves a preeminent, no, preeminent position, no, in the software engineering process today. And organizations failing to do so will find themselves struggling to compete. No, so how can security become part of the SDLC from the very beginning? First, testing early and open. No, a secure software development philosophy stresses employing static and dynamic, no, security testing throughout the development process. Second, development teams should also document software security requirements alongside the functional requirements. And finally, conducting risk analysis during design can be beneficial, no, in helping you identify potential environmental threats, because organization looking to offer secure software must lay the foundations for success by effectively preparing their people, processes, and technology for this challenge. And proper preparation takes the form of a well-constructed secure software development policy, which every organization is committed to building secure software needs. Okay, so what is a secure development policy? A secure software development policy is a set of guidelines, no, detailing the practices and procedures an organization should follow to decrease the risk of vulnerabilities during software development. So in addition, the policy should provide a detailed instruction on viewing, assessing, and demonstrating security through each phase of the system development lifecycle, including the risk management approaches. No? Later on, our presenter will be able to discuss about risk management in software development. So, okay. Now, secure software development policy must establish rules of your people or rules for your people. No? Team members must clearly understand their duties. No, receive through training or receive thorough training, no? And undergo strict employee screening, because instituting segregation of duties ensure no one person has total control or knowledge of a project, because testing protocols need to assess all employee work in order to ensure acceptable standard. So, secure software development policy must also discuss the necessary processes for protecting software. And one of the most critical is the separation of development, testing, and operational environments. No, breeds autonomy while preventing test bias and unauthorized code changes. Access control, another essential process, ensure employees can only access job relevant data. And finally, version control is helpful process to track all sources and times to code alteration. So, the first tech-related action step in a secure software development is policy should create the governing rules for programming languages and coding. Coding languages, no, can contain numerous vulnerabilities. No? So developers must be well-schooled on the hardening strategies that minimize attack routes. No? So a secure software development policy should also provide introduction to, or it must be provide instruction, no, on establishing secure repositories to manage and store code. So not only na secure software development policy recommended, but it's also mandatory in certain instances. Let's say, for example, organization adhering to SOC 2 Type 2 or ISO 27001, it must have a secure development policy, and your team can build your own policy from scratch or use resources like the ISO 27001 template guide. So, what should your organization keep in mind when creating a secure software development policy? No. So again, as Vice President for Engineering of Hyperproofs, Dave Brennan mentioned, no, you need to take a lot of different approaches. No, stay or you just start, no, by understanding what's happening in the industry and what the risks are. Next, you need to train your engineering team to be aware of common threats and vulnerabilities and the necessary process to follow and the tools to run. And finally, use checklists to ensure your policies and procedures are up to date and monitor this monthly or every month or every 2 weeks, every 3 weeks. No, it's not just an one approach that's going to keep your software secure. You're going to need all of them. Okay, based on Dave Brennan, the Vice President of Engineering at Hyperproof. So, using a secure software development framework to ensure consistency and best practices. Many organizations benefit from aligning their practices with a well-established framework, such as, I don't know if you're familiar with NIST, no? NIST Secure Software Development Framework, no? Or the NIST SSDF. Organizations such as OWASP, no, and SafeCode, no, have created a collection of foundational secure software development resources that discuss software security in detail, supplying the necessary guidance to reduce the number, less the impact, and prevent future vulnerabilities in software releases. No? So the NIST framework recommended secure software development process, which they organize into 4 stages. No? Number 1, prepare the organization. So they ensure that an organization's people, processes, and technologies are prepared to perform secure software development at an organization level and in some cases for each individual project. Number 2, protect the software. No, they secure or they protect all components of the software from tampering and unauthorized access. Number 3, produce well-secured software. No, software that has minimal vulnerabilities in its releases. No? And number 4 is response to vulnerabilities. No, they identify now vulnerabilities in software releases and respond appropriately to address these vulnerabilities and prevent similar vulnerabilities from occurring in the future. And each practice is defined with some elements. Number 1 is practice. No, a brief statement of the practice along with unique identifier and an explanation of what the practices is, practices is, and why it is beneficial. Another is task. No, an individual action or actions needed to accomplish a practice. And the implementation example, no, a given scenario that could be used to demonstrate a practice, no, and reference. So an established secure development practice document in each mappings, no, to a particular task. Okay? So how do they prepare the organization in the NIST? No, what will be their practices, task, and example for in preparing the organization? Again, this process begin by clearly defining both internal. We say internal, considering the policies, no, risk management strategies, and external, the laws and the regulations. So software development security engagement or even software development requirements for your organizations, no, SSDF rules, are assigned in teams prepared with rule-specific training. So supporting tools are engaged to improve speed and efficiency across the SDLC. Then security checks, no, are installed to ensure software meets of organizational standard. So in the task include identifying, communicating, and maintaining all security requirements over time. So training regimes are prepared, management support engaged, and tools selected. Now finally, benchmarks are defined to document, no, the achievement of set security standards. No, the example includes defining specifics, no, like coding practices and architecture requirement for developers, no, reviewing and updating security requirements at least yearly, especially after incidents, no, assigning SSDF related rules, training plans, then installing periodic reviews and preparing to update any rule changes over time, and defining tool chain, no, categories, no, specifying tools for each, and incorporating automation for tool chain operation and management, and creating an audit trail of secure development related actions, identifying key performance, no, indicators using an automated tool chain to gather feedback, and reviewing and documenting all security check evidence to support defined standards. Now, protect the software, no? Protecting the code and ensuring the integrity of software until it reaches the end customer is paramount. No? And this process focuses on safeguarding code from unauthorized access and tampering, verifying the software's integrity, and protecting the software after release. So a primary task is storing code based on the least privilege principle to ensure only unauthorized to ensure only authorized access. Now, also, a copy of every release with listed components and integrity verification information is provided to every customers. Now, example include storing code in insecure restricted access repositories, no, using version control to track all code changes, and posting cryptographic hashes to release software and using only trusted certificate authorities for code signing. So how about the practices task example in producing well-secured software? As you can imagine, this process includes many steps and involves numerous actors and practices. First, the software is designed and reviewed to align with identified security requirements. Next, the third parties are thoroughly evaluated for compliance with these requirements. Then developers use security best practices to write code, configuring the build process around boosting product security, and all code is then reviewed, analyzed, and tested, employing manual and automated means to uncover vulnerabilities and ensure compliance. And finally, employing manual and automated means to uncover vulnerabilities, no? And the software is configured with secure default setting for protection out of the box, and trusted components are open reuse in production. The specific tasks include creating a trusted component list, using threat modeling to assess risk, studying external security requirements, communicating standard to third parties while verifying their compliance, using secure coding, best practices while employing top industry tools, and examining code from all angles through review or analysis. And final tasks include designing and performing vulnerability tests, documenting the results, and fixing all discovered issues. Another important task, which some may consider as what I mentioned, is setting secure defaults, no? Ensuring they align with other platform security features, then explaining their importance to administrator. Examples include training a development team in secure building best practices and risk assessment techniques. The team also is studying vulnerability reports on previous releases while reviewing current design to ensure the all potential risks and security requirements are addressed, no, including security requirements and third party contracts, while creating policies to manage third party risk, avoiding all unsafe building functions and only developing an environment that mandate safe coding practices, using only current, no, validated versions of compiler build tools, no, employing a combination of peer reviews, dynamic or static analysis testing, and penetration testing to detect software vulnerabilities, then documenting result and lesson learned, no? Because creating an organizational repository of trusted building components is important, no? Verifying the setting of approved security default configurations and documenting proper usage to administrators. Then response to vulnerabilities, no? When it comes to practices and tasks, an example for to respond to vulnerabilities, no? So finding vulnerabilities is only part of security professional job. So the other critical component is remediation. So the final process focuses on correcting current vulnerabilities and gathering data for future prevention. So once identified and confirmed, vulnerabilities must be expediently prioritized and fixed, no? So speed is essential in reducing the window of opportunity threat actors have to launch attacks, no? Additionally, once mitigated, it's beneficial to analyze a vulnerabilities caused to help prevent future occurrences. Tasks in the final process include gathering customer information and diligently reviewing or testing code for any undiscovered flaws, preparing a team plan and processes for rapid vulnerability responses and mitigations, creating and implementing a remediation plan for each identified vulnerability, and determining the root causes to construct knowledge base for future prevention. In addition, root causes should be analyzed over time to identify patterns, no? And these patterns then can be spotted and remediated in the software, in other software. And finally, the entire SDLC can be periodically updated to eliminate similar issues and future releases. An example, of course, is creating a vulnerability reporting and response program, employing automation to effectively monitor vulnerability data and conduct automated code analysis, gauging the impact of and resources required to fix each vulnerability while prioritizing remediation, identifying and documenting root causes of vulnerabilities while advancing the tool chain for automatic future detection and implementing suitable adjustment to the SSDF. Actually, there are a lot of software security best practices. In today's constantly expanding threat environment, developing secure software is undoubtedly challenging, but it couldn't be more critical as more and more successful software link attacks grab headlines. So we complied a list of 10 software development best practices to help in building the safest software and keeping your organizations from becoming a software cyber attack statistic. So the top 10 software security best practices. Number 1, think security from the beginning. Before creating a single line of code, begin planning how you will integrate security into every phase of the software development lifecycle. Engage the power of automation in testing and monitoring vulnerabilities from day one. Now, security needs to be baked into your culture and code, and there's no better place to start than in the earliest development phase. Number 2, create a secure software development policy, because this will provide a guideline for preparing your people, processes, and technology to perform secure software development. Okay? This formal policy supplies specific instruction for approaching and instrumenting security in each phase of the SDLC. In addition, it provides the governing rules and defining rules to help your people, processes, and tools minimize the vulnerability risk in software production. Number 3, employ a secure software development framework. A proven framework like NIST, NIST SSDF, will add structure and consistency to your team's effort in adhering to secure software best practices. Frameworks can help answer the what do we next and question and benefits all new software developers. Number 4, design software with best practices to meet security requirements. Clearly define all security requirements. Then train developers to write code in alignment with these parameters using only secure coding practices. Ensure all your third-party vendors are aware of your security requirements and demonstrate compliance, as they can provide an easy pathway for an attack. Number 5, protect code integrity. Keep all code in secure repositories, allowing only authorized access to prevent tampering. Strictly regulate all contact with the code, monitor changes, and closely oversee the code signing process to preserve integrity. Number 6, review and test code early and often. Break away from the traditional development pattern of testing code toward the end of the SDLC. Instead, you use both developer reviews and automated testing to continually examine code for flaws. Catching vulnerabilities early in the life cycle saves money and time while preventing developer frustration later on. Okay? So be prepared. Number 7, be prepared to mitigate vulnerabilities quickly, because vulnerabilities are a fact of life in software development. It's not if they occur, but when. So be ready with a team plan and processes in place to address incidents in real time. Remember, the faster you can identify and respond to vulnerabilities, the better, because shortening the window of opportunity for exploitation. Number 8, configure secure default settings. Many customers remain vulnerable simply for lack of knowledge of their new software's functions. And this added customer service touch ensure the consumer will be protected in early stages of adoption. Number 9, use checklist. There are many moving parts to track and monitor during secure software development. Help your team by using action checklists at periodic intervals such as weekly or monthly meetings to ensure all necessary security policies and procedures are current and functional. And lastly, number 10, remain agile and proactive. Because a wise software developers study vulnerabilities, no? Learning their root causes, spotting patterns, preventing repeat occurrences, and updating their system development lifecycle with improved knowledge. They also watch trends and stay up to date on best practices. So Dave Brennan, the Vice President, as I mentioned earlier, offers some parting advice. Now, so the big picture is knowing and staying current on the industry and best practices. The space is always evolving. Security best practice approaches aren't standing still. So no matter what you're doing with security, it's critical to look ahead to see what's coming, keep learning, and identify better ways to secure your software development process. Okay, so how hyper-proof, no? So this will be an example, no, of a secure software development, no, under NIST, no. One of the most challenging part of maintaining information security is that people often don't follow through and complete their assigned tasks. Unfortunately, these human errors are most often at the start of security problems, no. So as organizations grow their technology footprint and evolve their business processes, security and compliance professionals need platforms that give them the ability to define security requirements, document and assign security tasks, monitor whether people perform tasks on time, and maintain accountability. So again, gain the visibility, efficiency, and consistency. You need to stay on top of all your security assurance and compliance work, said by Demo Hyperproof. So I think that's it for this topic.